For most of history, human senses seemed fixed. You could only see so far, hear so much, feel what your body could naturally feel. But military research has spent decades testing a different idea. What if perception is not a hard limit? What if it can be extended, retrained, restored, or fed entirely new forms of input, from seeing through darkness to feeling touch through machines? Here are 7 real military experiments that successfully altered the limits of human sensory perception. Military night vision did not just give soldiers a new tool, it gave the brain a new way to see. NASA researchers noted these systems require extensive training and perceptual adaptation. The human visual system had to learn to interpret a world filtered through noise. Once that adaptation happens, the user is not just seeing more, they are seeing differently. When the sensory input changes, the brain can change with it. Modern Army night systems combine image intensification with thermal imaging. Heat becomes visible, darkness becomes readable. Fused systems let soldiers see what a rifle is aiming at around a corner without exposing the body. It is a new sensory layer. NASA's work on synthetic vision creates a virtual visual meteorological condition that extends a pilot's capabilities when outside visibility is restricted. The pilot receives a constructed, navigable visual world generated from data. The brain begins using an artificial scene as if it were a functional environment. Vision is only part of perception. DARPA's haptics program was built to give wounded warriors sensor-equipped prosthetic limbs with sensory feedback. The goal is allowing users to sense the prosthesis through the same neural signaling pathways used for intact limbs, teaching the brain to feel through machinery. DARPA-supported researchers demonstrated that signals from a mechanical hand could be delivered directly to the sensory cortex, producing near-natural touch sensations. The object may be metal, the hand may be robotic, but the brain can still interpret it as contact. Fixed sensory boundaries start to collapse. DARPA's NEST program sought high-resolution neurotechnology for the visual and auditory systems, far beyond existing interfaces in scale and speed. If the brain can exchange sensory information with electronics at high resolution, human perception is no longer constrained by the body. Senses start looking hackable. The targeted neuroplasticity training program investigated boosting neurochemical signaling to accelerate long-term skill retention and target discrimination. It's about perception under pressure, the ability to notice faster, differentiate better, log onto meaningful patterns more efficiently. The sensory world may remain the same, but the brain becomes better at extracting signal from it, changing how quickly the mind learns to use it. These experiments all point to the same conclusion. Human perception is not as fixed as it feels.